100 years ago, Victor Hugo wrote, "Where the telescope ends, the microscope begins. But which of the two has the grander view?" Today, we still seek the answer. A Fine Science with Holly Preston.
Coming up, a look at some scientific projects at the University of Regina and the University of Saskatchewan. Besides their roles as learning institutes, universities often engage in research that relates to the community in other ways. On this program, how a team in the Regina Computer Science Department is developing inexpensive and practical solutions to assist handicapped people, not only at university, but in the workplace. In Saskatoon, there's a sophisticated lab capable of testing full-scale structures. Facilities are open for projects by private firms, or information collected by graduate students is available. But before we look at those stories, a very specialized project at the University of Regina. A research group is studying properties of the crystals of materials called organic semiconductors. Dr. Bev Robertson explains his research.
Well, this research group is primarily based around a research technique called X-ray crystallography. And our research group is involved in several projects, and most of them involve collaboration with other research groups in various parts of the world. A good example of one of the research projects within the group has to do with our study of a class of materials which we hope someday will play a role in our lives the way that silicon plays a role now as the basis of all electronics. This general class of materials are called organic semiconductor materials. Actually, we got involved with this project while spending some time working at the University of Stuttgart in West Germany. And we are still interacting with that research group, and we still communicate back and forth. They do certain kinds of physical measurements on the physical properties, the conductivities of the materials, and they actually form the materials. In Regina, we determine the precise arrangement of the molecules within the materials and the precise geometry of those molecules in order to try to understand the physical properties in terms of the way the molecules pack together and interact with each other. And another group in the University of Transkei, in one of the South African homelands, is working on the process of trying to make new molecules for us to use in these compounds. This is our main piece of research equipment. It's called an X-ray diffractometer. Now, to put this in perspective, of course, what we've been talking about already is that we're making an image of a molecule. The image may be represented by a computer drawing, for instance. And to make an image, we can make an analogy with when we take a picture. When we take a picture of something, we let light, which is a kind of electromagnetic radiation, fall on the object, and then we collect some of that through a lens. It could even be in our eye or through this camera, and that light is put back together into an image of the original object. Now, first of all, we're looking at molecules and atoms and molecules, so we can't use ordinary light, because that would be like trying to find a cork in the Atlantic Ocean looking at the waves that come in on the shore of Prince Edward Island, let's say. So we want to use a much shorter wavelength kind of electromagnetic radiation, and that's an X-ray, because the wavelength of X-rays is similar in size to the wavelength of the objects we're looking at, atoms. So the X-rays are generated in here. They are singled out, the kind we want, which are one particular wavelength in here, and the sample is back in here, and it is being irradiated with those X-rays. Now, because the molecules in the crystal are lined up in a special way, they are very symmetrically arranged, the X-rays only come out in special directions, maybe 10,000 special directions, but not in every direction. And this device orients the crystal and sends this counting arm so that the X-rays coming out come right through the apparatus and are collected here and counted. The next step is to take that information, which is the number of X-rays that come out in each one of these special directions, to put that together and do some calculations. We do the calculations because for X-rays we don't have a lens as we do in a camera or in an eye. We have to understand the process of information, of image formation very mathematically, and a computer calculation is used to generate the image. Now, once we have the precise information about the coordinates of all the atoms, we can make a computer drawing. And we can make it in stereo, in fact, and show ball and stick diagrams which represent very precisely the molecules. We also need to actually publish, in addition to that picture, for people who want to use make calculations with our results, the actual physical coordinates as well. But we have those two ways of representing the results. There are certain key situations in which the physical properties of silicon simply don't work because it's brittle, for one thing. And there are certain kinds of applications which have been actually been ongoing for quite a while now, where organic materials are used in semiconducting devices where they have to they can't be so rigid as silicon. Semiconducting materials of an organic nature are used in xerography, in reproducing images. They are used in solar energy conversion, to convert solar energy into electrical energy. Specialized batteries, and a number of other such other specific specialized applications. But I suspect that 20 years from now they'll be used in a much wider range of devices and so on.
The team at the University of Regina is involved in what could be called pure research. The information it compiles doesn't produce an end product in itself, but goes into a much larger international pool, including the Universities of Stuttgart and Transkai. As Dr. Robertson suggests, it could be some time before he sees a product produced as a direct result of his research. By using mathematics or scale models, you can calculate the strength of a steel girder, or you can use the same methods to determine if a concrete beam will stand up to severe weather conditions. But what if you'd prefer to test the actual girder or beam? You might take it to the engineering department at the University of Saskatchewan.
The lab was built approximately 5 years ago. It came into operation at the time, and it's incorporated with a new building. We were fortunate to get a large-scale lab for testing our various building components and bridge components. And in fact, it has to be of a large-scale size, as it is here, so that we can do realistic size testing. It's very difficult to model some of the larger building components with a small scale, the way you sometimes see little tinker toys and things. It's not quite the same. Especially with concrete, it's very difficult to get the same response in a small scale model as you do have in a real size structure. So the size is there for that reason.
What type of things might you be testing here?
We can do the whole gamut of structural materials, whether it be concrete or steel or wood. Very often we go into composite behavior, where we combine the better properties of steel and concrete, where we do have concrete slabs on the top, steel beams on the bottom, and they're connected together through shear studs, various types of mechanical connectors to make the two units act as a single unit.
You have an impressive piece of equipment for testing stress on beams.
Yes, we're quite proud of the testing facility we have behind us here. It's a MTS loading system. The way it's set up right now, it has 2 jacks, and the 2 jacks each have a capacity of 110,000 pounds. It's a double acting system where the load can be put on either pushing down in one direction, or you can have the same capacity pulling up. So in that fashion, we can test items where we bend them back and forth in the 2 directions. And here we are trying to simulate the behavior of either an earthquake, where you get shaking of the structure due to the earthquake motion, and the bending is taking place in both directions, or we may be trying to simulate the behavior of heavy trucks running over a bridge over many, many years, where you get maybe thousands or millions of load cycles, and this also is a very effective way. Certainly in Saskatchewan, we have to concern ourselves about how building materials are going to behave under the severe winter conditions we have. A very important problem there is the freeze thawing that we have very predominant here in Saskatchewan, particularly in the spring and the fall, where it warms up over the day and then freezes at night. This can be very destructive to concrete. In fact, if you go through the city, you'll probably find a lot of driveways where spalling of the surface has taken place, and some work has taken place in the laboratory here to try to monitor just what the detrimental effects are of the various types of climatic conditions we may have here in Saskatchewan.
Who actually uses the lab facilities here?
The lab here is primarily used by graduate students after they've got their bachelor's degree, after 4 years of training. Some of them go on to more training, and then they get into fairly extensive research projects where they do a particular test where they get very involved and spend maybe 6 months doing a particular series of tests to look at the behavior of some particular item, whether it be a beam or a column or a masonry wall. All these types of items have been looked at.
At Van Decor, our open to the public inventory clearance is now on. We're the leader in van conversions and quality accessories for cars and trucks, and now is your rare opportunity to select overstock items and save big. 10% off everything. Truck toolboxes, truck liners, floor mats, seat covers, grill guards, fog lamps. Save even more. 15% off running boards and sunroofs. Save best. 20% off pickup truck side rails and other selected items. Van Decor, 240 Hodgsman Road, Regina.
Get ready, get going. It won't stay long. Get that bold new taste before it's gone.
McDonald's cheddar melt.
Head for that beef, a quarter pound on a toasted rye bun, nothing like it around.
McDonald's cheddar melt.
With cheddar sauce, grilled onions too. A big bold taste from McDonald's to you. For a limited time, just $1.59. It's a good time for the great taste.
Cheddar melt.
McDonald's, just till March 1st.
When you're first exposed to computers, it doesn't take long to realize that they are visually oriented. Information is provided by video display or printout. But what if you have impaired vision or can't see at all? Researchers at the University of Regina are looking for solutions, answers that are practical and economical. We'll look at some of the computer-based aids they've developed, including a device that converts small print to large print when linked to a video display terminal, a voice synthesizer that speaks what's being shown on the screen at the same time, a machine that reads from standard printing and speaks the words, and a talking dictionary.
Well, this is our Mathesis talking dictionary system, and it was designed to fill a need that was found by a blind student here at the university who was a psychology major. And in his English and psychology classes, he found it necessary to do a lot of creative writing. And he found a problem in that blind people do not remember the way a word looks. They remember how it sounds. So when he has to do something in which he's got to spell the word correctly so another person can understand it, he runs into a problem because he doesn't remember how to spell it, and he doesn't really have any facility that he can use to go and find the spelling. This is a complete dictionary, like a pocket dictionary, which one might use for that purpose. You can simply type in the word, and the information comes out through a voice synthesizer.
Can you show us how it works?
Certainly. And take a word such as abacus.
A-B-A-C-U-S.
Have it search for the word in the dictionary.
Exact match.
Okay, it tells me it has an exact match because that's a correctly spelled word. And then I can have it recite the definition for us.
Abacus, noun, one.
It is not necessary to know the exact spelling of the word in order to find it. That's one of the improvements that we've made here to make the whole system work. If you know how it sounds, the computer can take what you type in and reduce it to a phonetic code based on your spelling, and then match that phonetic code to the spellings of the words in the dictionary. So I can type something like
A-B-I-A-U-S,
which is incorrect.
No exact match. Two approximations.
Okay, it's found two approximations. The no exact match means, of course, that there's no word with that spelling in the dictionary. So I can simply hit the space bar and get the two words that it's found. Abscissa and abacus are the two words that it found that could be what I'm trying to get at with what I typed in. And then you can select each one of those, ask for the spelling of that.
B-A-C-U
and there's the correct spelling. And that has nothing to do with the way I typed it in the first time.
How's this been working?
Fairly well. What you see here is an experimental system. There are a few delays once in a while. It's slower than we would like it. And the only development that actually remains to be done on it is to rewrite it in machine language instead of a high-level language the way it is now. And that'll improve the speed so that there will be no noticeable delay, either in searching for the word or between phrases of the definition.
Where will the equipment go from here if everything works out for you?
Well, there will be this system, which will remain here for public use. This room is used for equipment that is accessible to the students on campus. One copy of this system will also go in the public library on campus, and a similar system could go in the Regina Public Library. And we have had requests from other universities to send them a copy of this system that they might put it in their resource centers. So it'll be available to anyone at a university who requires a service of this kind.
This is a fairly inexpensive voice synthesis unit that will allow a user to have, a blind user to have immediate feedback on the keyboard, hear what he's typing, and have everything on the screen represented in audio, so it knows exactly what's being sent. It's slow, as I said, most of the software on a system, computer system, is visually oriented, i.e. menus and whatnot, but he can get the work done, whereas before he couldn't.
So is it going to be possible to increase the speed of it eventually?
Oh, eventually. This unit is limited, but the new systems that they're coming out with are fairly flexible. But you can only hear something so fast. Like anybody can read a lot faster than they can hear something. This voice unit just runs off any line that you'd normally plug a terminal into. It's the same thing. Like virtually any computer system you could plug this into and it would run.
This is not under development. This is a utility that is finished and available to many students on campus. Anywhere where there is an XT100 terminal, and there are some 20 or 30 of those freely available for public use. The machines that we work on here are mini computers, and as many as 15 or 20 people can work on one at the same time. It's not necessary to be in the same room as the machine. So to use this utility, you can type a command line like this, and then the information coming from the computer is displayed in characters twice as high. So this can be used by students with partially impaired vision, not totally blind, who cannot easily read the small characters on a standard computer terminal. So we can just log on to any other machine on campus through this special connection. Well, this is the standard size of print that you have on a computer terminal. If we invoke the larger size, you'll see this looks quite small, but what we do is expand the height to twice the standard height of the character and leave the width exactly the same. And this is the result. It looks a lot bigger, and that's all one really needs to make the output from the computer a lot easier to read.
Oh, say, can you see by the dawn's early light what so proudly we hailed? And that will
highly sophisticated equipment such as this American-made reading device is available. It reads and reproduces typewritten pages. Needless to say, it's very expensive. Steve Grieve is developing a unit at the university to perform similar functions, but at a much lower cost.
It's a device that will take a standard typewritten sheet of text and read it into a computer, and then the computer will speak those words, and it allows a blind person to take correspondence and be able to work in a standard office with that correspondence. Really, the heart of the device is this small unit here, which consists of two infrared lights that illuminate the page, and this chip in the center, which actually senses picks up the text off the page, and the chip is has its top removed, as you can see there, and light-sensitive array is exposed to the page. The other part of the unit is this housing, which contains a small lens in the center, which focuses the print onto that light-sensitive chip. The other major purpose of this project is to be able to construct this device inexpensively, and so we're using standard off-the-shelf hardware, and it consists of a Bosch and Lomb plotter, IBM microcomputer, and a character scanner that was developed in England just this past year.
End of demonstration.
You may have noticed that some of the voice units are difficult to understand. The computer science department says that in fact the users become accustomed to the sound quality and have no problems with it.
Siegel's is Regina's oldest and finest independent furniture store. Since 1945, we have sold distinctive, quality, famous brand name furniture for apartment and home lifestyles. Sklar Pepler, Andrew Malcolm, Bauhaus, Braymore, Electrohome, Lazy Boy, Liberty, Nadeau, Sealy and Simmons. At Siegel's, you're assured of quality furniture and unsurpassed reputation for fair price, service, and workmanship guarantee. Visit Siegel's, 1825 7th Avenue.
You saw me crying in the chapel.
Quality Records presents Elvis Classic Love Ballads, 16 memorable performances.
Are you lonesome tonight?
Relive the magic that was Elvis. Elvis Classic Love Ballads will become the most treasured in your collection. In stores for the first time in Canada, Elvis Classic Love Ballads from Quality Records.
My dry cleaning isn't ready, sir. I brought it in a week ago. Yeah, that's right. The slacks, the jacket, and the dress. No, sir. The dress belongs to my wife, okay? Yeah. So it won't be ready till next week. Okay, fine. Sure. How much is this going to cost me? $73.95? I tell you what, sir. No, you can keep the clothes. I am not paying these prices. Don't yell, sir. I don't care if the dress isn't your size.
When quality and service matter, try us, Queen City Cleaners, with 5 Regina locations.
Men and women who wouldn't think of pointing a loaded gun at a fellow human being think nothing of drinking and driving. Drinking turns a car into a lethal weapon. Disarm a drunk. Don't let him drive. Let's not meet by accident.
Besides the projects to help the visually impaired, Dr. Brian McGuire is trying to adapt a system for the verbally impaired. PIC uses small illustrations to communicate ideas and objects. It could possibly be transferred to a computer-based system as well.
These are pictograms, and the nice thing about it is I can walk in and point on my board or fire out the symbols. If I go into McDonald's and I say I want, I'm nonverbal, remember, and I may be mentally handicapped, so I really don't have any way of communicating very well with that person behind the counter. But if I hold that out, then they're going to know I want a hamburger. I can go for fries, and I can have coffee. We don't have a milkshake in here, so we're sort of stuck on that. My problem, of course, is I don't like, we've got a symbol for cheese, so I could get a cheeseburger. But I don't like any of the other things on it, so I'd have real trouble with this because we don't have anything to communicate that that I want a cheese PL sort of thing. But we don't plan to replace the actual use of something like the PIC board. What we're really just looking for is to create learning systems that could be used by institutions. We're not looking at a lot of money for a system like this. The microcomputer would be a few $1,000s, and presumably as well within a budget of an institution that had adopted the PIC system, and also probably well within the budget of a lot of families, especially since there's a lot of aid available to buy these sort of aids for handicapped individuals. And of course, with a microcomputer, maybe the family will use it for other things. So it could be used in the home, but we're probably gearing mainly to institutional learning. This system is primarily a pictogram system in that there are definitely more pictograms or pictures of, in essence, of real things than there are ideograms. For example, that doesn't mean two people, it means friends, and they have their arm around each other. But now you're trying to express an idea, and of course that's always where you have some problem with that. Crowd, well, maybe that comes through as crowd. Could come through as a lineup for a bus too. And of course, family. Now, that's not too bad. I mean, I think most people, if they looked at that, would perceive family. But these ideograms are a little harder for a non-trained person to look at and say, oh yeah, I know what that means. But that's the sort of learning system we're going to try and develop, is just to be able to call these up on a screen, reinforce the learning process.
So it will be, as you suggest, a teaching aid.
A teaching aid.
We've just scratched the surface of the work that goes on in our universities outside of the regular classrooms. They play a very important part in scientific research and development. And that's our program. I'm Holly Preston.
This is CBC Television.